everyone. Today we're going to be looking at 13.1, looking at circuits and drawing circuit diagrams. So remember from our very first lesson in chapter 12, we learned about current, electricity, and that has to do with electrons flowing in a circuit. And when we're taking a look at a circuit, electrons will flow out of the negative end and it'll go around the entire circuit and back into the positive end into that same cell or battery. So we have our power source here, and when we're drawing our circuit diagrams, we always show the negative end by drawing a minus sign. The flow of electrons is going from right to left in this case, back into the positive end of the battery. So circuit diagrams can become very complex, but we're just being introduced to drawing them. So we'll take a look at a couple of examples. First, we need to know that there are two types of circuits. The first is called a series circuit, and this is when you have loads such as a light bulb or a motor that are connected end to end. So there's only one path for electrons to flow. So if you were to put your finger on one end of the battery and you're running your finger along the circuit, it only has one path that allows it to go back to the positive end of the battery. So electron flow is only in one path, one direction. So plugging a toaster and a kettle into one outlet, and it is an example of two loads on the same circuit. If that fuse blows for that outlet, none of the toaster or the kettle will work. So you'll notice that in our houses, a lot of circuits are not in series for that reason, because if one of the circuit blows out and it does not work, everything attached to that outlet will not work. So usually the circuits in our homes will have parallel circuits. So how do we draw this? There are a couple of symbols that we should know or we should remember before we draw circuit diagrams. So on the side here, I want you to draw some symbols for us to remember. The first is, remember that we need a battery source. So there are multiple battery sources that we may be asked to draw. The first one is a one-cell battery. We have a two-cell battery. And then three of these pairs of lines is a three-cell battery. Okay, and always remember to draw the negative and the positive end of your battery. Okay, at the negative end, we have electrons flowing, and the electrons flow back into the positive end. The other thing to draw, and you'll see a lot of this, are your light bulbs or your lamps. Okay, so a lamp is drawn like so, with a squiggly line in the center, and then you draw a circle around it. The next one is a motor. So motor symbol, capital M with a circle around it. And these lines here are just the conducting wires. We also have the switch. So when you go to turn on a light and you flip it up, you have closed your switch. So this is a closed switch. When you turn off your light, we have an open switch. There's also something called a resistor. And that's it for now. Okay, so let's take a look at the first example. It says draw a circuit diagram of the following circuit using the correct symbols. So there are 3 loads. In this case, when you see loads, you can automatically think light bulbs. Connected in series, powered by a 3-cell battery with a closed switch. So let's highlight all of our necessary parts. So there are 3 loads. They're connected in series, meaning they follow each other one after the other. 3-cell battery and a closed switch. So we should always start off drawing our battery. So it's 3 cells, negative, positive end. There are 3 loads. 1, 2, 3. Okay, you could have drawn all 3 on this side, and that's okay. Or you could have drawn all 3 on this side of your circuit, or all 3 on the other side, or 2 on one side, 1 on the other. As long as they are in series, meaning if I were to draw a line starting from the negative end and going to the positive, there's only one path for the light bulbs, or for your path to go. There's only one path, then that is in series. There's also a closed switch. So before my light bulbs, I'm going to draw a closed switch. You could also have drawn your closed switch at the end, and that would be correct as well. Okay, so either before or after all of your loads. So that is a series circuit. The next one is a parallel circuit. So a circuit where the loads are connected by branches, meaning there's 2 or more paths for the electrons to flow. The loads of this circuit are on at least 2 different branches of wires that end up connecting to an energy source. So this allows for electrons to flow through different branches. Some electrons will follow one branch while others will follow another branch. The separate paths meet up before returning to the energy source. So the separate paths meet before returning to the energy source. So let's take a look at an example with a parallel circuit. So we have 2 light bulbs connected in parallel, powered by a 3-cell battery with a closed switch. So again, let's draw out our battery. There's 2 light bulbs in parallel. So that means that when you go to draw a line over your circuit, it needs to have 2 different paths for the light bulbs to be on. So my first one will be here, and then you can draw another vertical line for the second light bulb. So let's say I am looking at my flow of electrons. Electrons can either flow to the first light bulb here, or it can flow to the second light bulb and return back to the battery. It is also being controlled by a closed switch. So again, you could either put it at the very end before it meets the positive end of the battery, or it can be placed before, right when it leaves the negative end of the battery. Okay, so we have some practice over here using circuit diagram symbols. Draw a circuit diagram for each of the following. So you are going to complete 1, 2, 3, 4. Once you are complete with these 4, you can move on to completing the homework from the textbook, which is going to be 13.1, page 554, numbers 1 to 7.